All right, so the warm-up. I want you to take a second and go ahead and convert the following cubic function into standard form. You've done this last chapter. Remember, all you're doing is distributing. So take a minute with your group and go ahead and see if you guys can distribute that all the way through and write it in standard form. Remember when you distribute that 2x inside, you only distribute to one of them. If you do it to both, you're double dipping. Okay, you can either choose to do that first or wait to do it at the very, very end. Either way is fine. But when you distribute it in the beginning, if that's your choice, remember you only do it to the first group or the second group, whichever one, doesn't really matter. Okay, but you can only do it to one. Okay, a lot of you are flying by, and that's great. So remember, when you do this, you only distribute to one of them. So I have 2x squared minus what? Good, 4x. Now, this is all still a group. Do not apply it to the second one. Okay, that would be double dipping. Only apply it to one or wait to the very end to finish it off. This is where you would do the first, outer, inner, last, FOIL, distribute. So we would have 2x squared times x, which is 2x cubed. Then we would have 2x squared times 5. Good. Plus 10x squared. Do you have questions on that one? Okay, now we have to take that second piece, that negative 4x, and we have to distribute it to both of them. So what's negative 4x times x? Beautiful. And then what's negative 4x times 5? Good. Negative 20x. Do you have questions on that step? On how I got any of that piece? My last and final step here is to combine like terms. What's like terms here? Good. I have negative 10x squared and a positive 10x squared and a negative 4x squared, and that makes what? Good. 6x squared. And I'm going to bring down my 2x cubed and my negative 20x. And that is my final answer. If you ever wanted to check your work, there is a way. You could plug in your calculator, your graphing calculator. This very first one, 2x times all that, and then plug in this last one. What you'll notice, and this is how I check my answers, when you plug in the calculator, you're going to get the same exact function. It's really, really cool. So if you ever wanted to do that, if you plugged in both of these separately, you'll see that it's the same exact function, and that's when you know you got it correct. Okay? Any questions on the very first warm-up? All right, got lots of that today. Lots of distributing, lots of algebra. So let's continue on. So this says, write a polynomial. So write a polynomial function f with a least degree that has a rational coefficient, a leading coefficient of 1, and the given zeros. So remember, a rational coefficient, that just means that you can write it as a fraction. It's a real number, and we can write it as a fraction if you don't know what rational is. When we have a leading coefficient of 1, that's that when we have a to the x to the n power, this is your degree, and this is your leading coefficient. So the degree of the polynomial in this case is probably going to be 3, because there's 3 zeros. Okay, so that leading coefficient in front of that x cubed is going to be 1, and that should make you very happy because that's the easiest type of problem. is when that a value all the way out in front is 1. So remember, when we write out zeros, and I know a lot of you were doing this when you guys were walking in and you were asking me if it was correct, and you guys did a very, very good job. When you write out your zeros, we would write it as x minus your 0. Okay, so when we're writing out our zeros, when we're writing polynomials, it's going to be x minus your 0. So let's go ahead and write this one out. So I have f of x equals x what? What'd you say? Well, x cubed is going to be your ending result, but we have to get there first. How would I write the 0? Yeah. Good, x plus 5, because remember, your 0 technically is x minus 5, but because we have a negative 5, it changes that minus sign. Okay, so then what would be our next one? Good, and very good. Okay, so when you're writing out your polynomial function given the zeros, it's really just that opposite sign. Okay? Well, now we can distribute, and we're all good at algebra, so we know we can do this, but take your time. These ones can be a little bit tedious. Make sure that you're staying organized when you're writing these problems out. So we're going to do that first group first. Here we go. What is x times x? X squared. Then what's x times negative 2? Good, negative 2x. Done with that first one. I'm going to move on to that 5. So I have 5 times x, which is beautiful, and then 5 times negative 2, which is very good. Do you have questions on how I got that one group right there? Again, next step here is just to combine the middle terms, combine like terms right here. So I'm going to combine them, and I get x squared what? Yeah, plus 3x minus 10. Bring down your x minus 3. Do you have questions up to this point on how to distribute that? Remember, you're taking each piece and multiplying it to everything. So I took the x and I multiplied it to x and negative 2. I took the 5 and I multiplied it to x and negative 2. Now, here's the tough part because now we have 3. But that's okay. Just take your time. Here we go. Same type of problem. X squared times x is good, x cubed. X squared times negative 3. Okay, so now I'm done with this x squared. I'm going to move on to the middle one. So I have 3x now. So 3x times x is good. So I have positive 3x squared. And then 3x times negative 3. Very good. Do you have questions on that one? I still have one more. If you notice, I have not touched this negative 10 yet. I have to keep going one more time. So I have this negative 10. So negative 10 times x is good, negative 10x. And then negative 10 times negative 3. Good. So again, each and every single one of them, I have to multiply to the x and to the negative 3. My final step here is just to combine like terms. So I have these x squareds, and I have these negative 9x and that negative 10x. What happens to my x squareds? Good. They're going to, oop, that's supposed to be not a highlighter. They're going to cancel out. Very good. And my final answer here is going to be x cubed. What's negative 9x minus 10x? Good. Negative 19x plus 30. And we're done. Again, a great way to check your answers, and I'm going to walk you through this one just to show you, to prove it to you, when you check your answers on that graphing calculator. So let me get my graphing calculator out, and I would get yours out, because I know sometimes we second guess ourselves on an exam, and we want to check to see if we're doing it correctly, and this is a perfect opportunity for you to do that. Or if you're thinking about it, if you have a multiple choice on the SAT, you could just type in each one of them and see which one matches your graph. If you forget how to distribute, or if you don't want to waste time distributing, you could just do this trick and save yourself a lot of time. So we would go to our y equals, and let me clear this out. For some reason, it's really small. Okay, so I'm going to go ahead and I'm going to type in each one. I'm going to type in my very first one. I'm going to type in my x plus 5 Close it up. I'm missing an x, aren't I? X plus 5, close it up. Then I have x minus 2. Close it up. Then I have x minus 3. Okay, that's my first one. Then I'm going to go down to my second one and type in my answer to make sure I got it correct. I'm going to type in that x cubed, x caret 3. I have to go to the right in that situation so I'm not in that exponent still. And then I have minus 19x. And then I have plus 30. Was that it? That's what we got, right? I'm going to press graph. If you watch, the blue one's drawn. And then that red one is drawn. If you notice they're the same exact line, you did it correctly. They should be equivalent to each other. Okay, so great opportunity for you to check your answers. Yes?
Well, I mean, this doesn't really apply to me because I also have the color calculator, but if you have the black and white calculator, it doesn't do those different colors.
You're correct. However, you wouldn't see another line. And if you select each one, again, they'll start, I practiced that. Yeah, you're just going to see one line. You shouldn't see anything shifted. If I typed in one thing wrong, if I go back once and I type in this to be like, I don't know, move this over. Let's just say I made this a positive instead on accident. Okay, that's going to change everything. So there's my blue one. And then you're going to notice my red one. Again, you might not have the colors, but it's going to be different. You're going to see a completely different graph. Okay, does that make sense? Great way for you to check your answers. So I want you to give the next one a try because it's the same exact type of problem. So see how you do on that very next one. I'll give you a couple minutes. If you need help, I'm right here. Sorry. What'd you say?
I think I'm doing it right.
You look good there. We'll leave. This becomes what? Can't cross this part out yet. Okay, so this is why you have so many. This actually will be fine. Did you distribute all of these?
Yeah.
Okay, wow. You're gonna be fine. You said to keep, now you have to minimize.
Okay.
So what I would recommend in the future, so you don't have that many terms, combine them.
Okay.
Because 1 minus 4 is 9. Okay. But you should be okay. You just gotta keep going ahead.
Right.
Rock stars. You guys are doing very well with this already. I like the boxes. That keeps you so organized. Oh, you guys are flying through. 3 and 4 are a little different. I'm going to zoom into mine, slowly check your answers. Again, I would not check them until you are done. Then check your answer, see how you did once you finished. See how you have enough x squared for them too. That's what happens when you got a lot. That's okay though. So, again, check your answers. My recommendation to you is that you combine this x and this negative 4x before you move on. If you choose not to, it's okay. It'll still work out. You just have a lot more work going for you. You'd have to distribute the x and the negative 4x. And I walked around, a couple of you did that, and that's okay. Just be careful that you don't miss something when you don't combine those middle two terms. Do you have questions on this one before I move on? Make sure you have that completely copied down. I'll give you another 30 seconds. And then we'll move on to a little bit different, not too much, but just a little bit. Did anyone check their answer in their calculator? Nice. Good. Okay. Some of you still writing down, that's okay. I'll give you another couple seconds here. Okay, so I'm going to move back here. And we're going to try something a little bit different, not too much different, but I know you can do it. A little bit more algebra, but you can do it. So in this situation, we're going to write a cubic function. Well, what degree do I have if it's cubic? 3. Okay, that means I need to have x cubed at some point. And I have these 3 zeros. We're not giving you the zeros like the zeros are this, but if you notice, all of them have that y being 0. That means that that's going to be your 3 zeros right there. However, they give you now this random point that's on the function. So now we have to find that leading coefficient because it's not 1 anymore. So we have to figure out what that leading coefficient is. So my very first step in these problems, I'm going to find that leading coefficient. Okay, so that's my very first step when I do this. I have to find the leading coefficient, which is we're going to label A. We normally do label our leading coefficient A. Okay, so here we go. Remember, I'm given this point. That's going to be my x value, and this guy is going to be that f of x value, that y value. So when I solve for A, I have to plug those two things in. This is going to be one of my zeros. This is going to be one of my zeros, and this is going to be one of my zeros, all green right there. So let me go ahead and plug that in for you. So I have my f of x, which is negative 36, equals, same problem, but instead of x minus 0, I'm going to plug in my negative 1 because I know what x is in this situation. So in order to find my leading coefficient, I have to plug in that negative 1. So I'm just going to color code it for you guys. I was going to plug in that negative 1 in purple minus 0. I'm just going to put in the minus 0 so you can see it. Then again, I have x minus negative 7, which becomes a positive. But remember, my x value is going to be that negative 1 plus 7. Again, now I'm going to plug in that 2. So I have that negative 1 minus 2 because that's my 0. Do you have questions on that part? If you notice, I wrote it exactly the same as what we did up here. These would just normally be x's. But because I know my x value, I can plug it in. Well, this is actually pretty straightforward. Oh, I forgot my a, guys. The a goes right here. That's my fault. Don't forget that a value. We're looking for that leading coefficient. That number that's all the way out in front next to the equal sign. Well, in your calculator or in your head, go ahead and plug that in. I should get negative 36 something. Think about it. I got negative 1 times a positive 6 times a negative 3. What do you get? 18. Very good. So I'm just going to write that out for your sake of your notes. I got negative 1 times a 6 times a negative 3, which gets me that 18. I'm going to keep that a in red because I want to make sure that you understand that we're solving for a right now. What do I do to both sides here? Good, I divide by 18. And what did we get for our leading coefficient? What'd you say? Negative 2, very good. So now it's the same exact process as number 1 and number 2, except for now I have to add that negative 2 in as my leading coefficient. Okay, so same exact thing. So here we go. Step 2 is I'm going to do that same exact thing I just did above. I'm going to write that function out. I have f of x equals my leading coefficient of -2. And now same process as before. X minus 0, but I really don't need that x minus 0, so I'm just going to put x. And then I have that x plus 7, and I have that x minus 2. Go ahead and distribute, because I know you can do that. It's just like that very first warm-up. It's just like that one. So the only thing that's different is finding that a value, that leading coefficient, before we actually do the writing the function. You guys are doing very well with this. When you're done, only check your answers. Lots of algebra. You got this. Let me know if you need any help. So up around, looks like you guys are getting it. That's great. Can check those answers. And then I'm going to challenge you with your group or with yourself to do the next problem. It's the same exact thing as what we just did, just a different set of numbers here. Challenge yourself to do that next one. Same process. Find a first, and then move on. The back side's really fast. It's all good. Yep. Remember, unless I say that the leading coefficient's 1, you have to find it first. Try to move on to 4. 4 is a little bit more challenging, but definitely the same process. I love seeing you guys checking your answers on your calculator. That's awesome. Yep. You're doing awesome. How's that with the shoulder?
Yeah, that's good.
You getting better?
Yeah, we know that.
Let me know if you need any help. So this part, you're just going to be plugging in, you would put it in here with your zeros. Okay, and then just having that 3 out the box. Okay? You stressed out? I'd be stressed. You're stressing me. I was stressed. I used to be stressed. And here. It was like, I'd be out there. But we did not say it. Okay, but we'll talk. I'm just going to put this up there in case you need a guiding hint or if you want to check your answers because you're done, 'cause some of you are. try to color code it for you, so you can see where everything is coming from. Glad you got the value of the leading coefficient to be 3, and that's awesome. That's an accomplishment. Now go ahead and plug that back in. The distributing's a little bit harder on this one, but challenge yourself. Give it 2 more minutes. And check your answers in the calculator, and if you see an error, so you kind of look at mine and see if you can figure out where you went wrong. It could have just been a sign that you missed. Very, very good. Another minute. It's got to be very organized with your work in these types of problems. Seems like most of you are done. Did you have any questions on this one? Was there something that that threw you off you'd like me to go over? You guys did very well when I walked around. You got the right answer. That's awesome. Give you another 30 seconds just to make sure you got all of this. Yes. All right, awesome. Let's flip to the back page here. Pretty straightforward, just kind of some, oop, I don't want to give you the key. Nah. Okay, so there's 2 different kinds of theorems. We have complex conjugate theorem and we have the irrational conjugate theorem, okay? So if f, this is a complex conjugate theorem, if f is a polynomial function with real coefficients, that's any number that exists. That's what a real number is. And a plus bi, okay, that's just kind of a general statement here, is an imaginary zero of f, then we know that a minus bi is also going to be a zero of f. Okay, that comes from the quadratic formula. That's where that's coming from. When you take the square root of something, you're going to have plus and minus, and that's why we have both a minus bi and a plus bi. Okay? Then we talk about irrational conjugates. Remember, irrational numbers are numbers that can't be written as a fraction. Okay? So like pi 3.1415926, I don't know the rest of it. Okay? Suppose f is a polynomial function with rational coefficients. And a and b are rational numbers, such that the radical b is irrational. Okay? If radical b is a 0, then we know negative radical b is also a 0. Okay? So again, that's just coming from that quadratic formula. Oop, I missed something. A plus B, radical B, and A minus radical B. Okay. Questions on that? That's just kind of something for you to have in the back of your mind. Okay. That's going to help you when you're counting to make sure that you have the right amount of zeros. If you have a 5th degree polynomial, you have to be able to count 5 zeros, whether they're imaginary or if they're real. So let's kind of just talk about some situations here. Jerry found that a polynomial function had the following zeros. I have 8, -3, and 4 minus I. So in this situation, I'm going to highlight this little piece here. That 4 minus I is going to be what theorem? The first one, the complex conjugate. So what also is going to be a 0 in this situation? Yeah, 4 plus I. Okay, whenever you have an imaginary number, there has to be the duplicate, that opposite of it. So when you're now counting these zeros, we have to talk about which ones are real and which ones are imaginary. How many real ones do I have? 2. These guys are real. How many imaginary do I have? 2. This guy is imaginary and that guy is imaginary. So how many total zeros do I have? 4. So that's my degree. What is a 4th degree polynomial? Does anyone remember? It's a weird name. Yeah, a quartic. I heard someone say it. Quartic. Okay. Pretty straightforward. Let's do the next one. George found that a polynomial function had the following zeros: 6, 4, and 6 and 4 minus 3i. So right here is going to be that situation where I have that irrational conjugate theorem. So if I have 4 minus 3i, what must I also have? Plus 4 plus radical 3. Very good. So now, how many real zeros do I have? It's kind of, are you sure? Are you sure? I have 3. These aren't imaginary. They're real. Okay? So these are real zeros. They're not imaginary. They don't have eyes in it. They're still real. That's kind of like the trick there. Okay? So don't let it trick you there. So I have 1, 2, 3. I have 3 and I have 0 imaginary. You have to have an I for it to be imaginary. Okay? So state the degree. What's the degree? 3. And what kind of function do I have if it's 3? Cubic. Good. Last one's got a bunch of it in there, got a couple of things going on. Elaine found that the polynomial function had the following zeros: 0, 1 plus radical 3, and a 3i. So these are 2 different situations. I have this 1 plus 3i, and I have a 3i. Sorry, 1 plus radical 3 and a 3i. So in this situation, I'm going to have that 1 minus radical 3. And then what else should I have? A negative 3i. So again, whenever you have a situation like this kind of looks like that quadratic formula. Whenever we're done with it, it looks like that would be the result. Same with this. Okay, that's why we have to have that opposite of it. So how many are real? 3. Here, 1, 2, and 3. I have 3 reals. And how many imaginaries? 2. So what's my degree? Anyone remember what the 5th degree what'd you say? Good, quintic. It's a weird name. Okay. All right, not too difficult. You got this. Okay, the homework is exactly the same. It's 1 page, the same exact setup as your notes. So make sure you're using that notes as your guide. Okay, you have a good 8 minutes left. You can at least finish 1 problem or 2, depending on how fast you are with your algebra. Hope I gave you a good finish. Remember, good work today.